Hello, this is Professor Gina, and I am making this video to go over the problems that were on the last exam that we took, mostly just to help you prepare for those that are going to be doing a retest. I want to start with the items that will not be on the retest because these are the two problems that most people got correct. So not on the retest. There was a problem about Euler's formula. It gave you a particular set of characteristics, like maybe a prism that had 18 edges, and you had to determine how many vertices or how many faces or something like that. Most people were able to get those problems correctly, so that won't be on the retest. The other one that won't be on the retest is the volume of a sphere, though I do want to talk about that briefly. If you did get some of the points marked off, it's because you either used the pi symbol on your calculator or you did the calculation with a calculator on Google, which is not what I was asking you to do. But the volume of a sphere, the formula is 4/3 pi r cubed. And in the directions, I asked you to use pi approximation as 3.14. The reason for that is standard within elementary school, that we'll use 3.14 as the variable replacement for pi. If you type the formula of for a given radius into Google or into any calculator that will use the pi symbol, it's going to give you a different decimal output than if you type just 3.14, and so there were rounding errors. And so if you missed some of the points, that's the reason. But most people knew how to either find that formula or use that formula, so those two items will not be on the retest. All right, so the next set of things is what is potentially on the retest. The first two problems were to find the perimeter of a shape, and then to find the area of a shape on the geoboard. All right. Now, a couple of you found apps that will calculate the things on the geoboard for you. That is not what I was asking you to do. I wanted you to be able to calculate these on your own because these are problems that you will see when you're teaching elementary school. So for the perimeter, first thing that I want to talk about is that some of the counting that was used was incorrect. I want to just overemphasize that when I go in between two pegs, that's going to be one unit. And then when I go between another two pegs, that's a second unit. And in between two pegs is 3 units. So we're not counting the individual pegs. In this particular case here, I have 4 pegs, but I only have 3 spaces. And we're counting the spaces in between when we're talking about perimeter. So that's the first item that you need to keep in mind. All right. So on this particular figure, I've got 1, 2, 3, 4, 5, 6 spaces. This side is 6 units long. 1, 2, 3, 4, 5, 6, 7, 8. This side is 8 units long. And this one is 4 units long. So that gives me the easy parts of finding the perimeter. To find the other two lengths that are diagonals, what I'm going to do is consider the triangle that is created like this. This side of the triangle is 4, and this side of the triangle is 3. So using the Pythagorean theorem, I would get that this side is 5. Okay. And then this side, this other triangle, this side is also 4. And this side is 5. So for that second one, I would have, let's call this side C. C squared is going to be 5 squared plus 4 squared, which is 25 plus 16, or C is the square root of 41. So for this particular problem, the perimeter will be 4 plus 8 plus 6 plus 5 plus the square root of 41. Add all this together. The exact answer would be 23 plus the square root of 41. And the approximate answer in decimal form is 29.4 units. One of the things that I want you to consider for all of these problems, especially when we get to the surface area and volume, is to not plug things into the calculator until the very end. Some of your answers were very close but off by rounding. And when we are in elementary school, we have to be very precise with the calculations. We want to leave answers in their forms with square roots until the very last step and then plug into the calculator at the end. All right, so that's the first example talking about perimeter. The second example was asking for the area. We had the formula that we used called Pick's formula that counted up boundary points and interior points. And some of you approached the problem in this manner, but I think the easier thing to do is to actually subtract off the triangles that are not included in this shape. So I intentionally made the area of the geoboard to be 10 by 10. So the total geoboard, I'm going to use a different color just to is 100. All right, so I'm going to start with 100 as the total, and then I'm going to subtract off 4 triangles. So I've got this triangle on the outside, which is 2 by 7. Now, because each side is 10 by 10, I know that this length is going to be 3, because then the 3 and the 7 add up to give me 10. This length is 4. So then this length here is going to be 6. This length here is 2, so this length is 8. And then this length here is also going to be 8. Again, if you look at all all sides, both numbers should add up to 10. So I've got 4 triangles that I'm going to be subtracting the area of, right? So let's call this triangle A, let's call this triangle B, C, D. All right, so the area of A is equal to 1/2 2 times 7. And B is 1/2 3 times 4. C is 1/2 6 times 8. And D is 1/2 2 times 8. So this is 7, this is 6, this is 24, and this is 8. So I'm going to find my total area will be 100, and then minus all of these numbers. So in this case, the area of the shape on the inside, that quadrilateral, is 55. All right. So those are the first 2 examples. The next 2 examples I'm going to look at are finding surface area and volume. We had 2 prisms. One was a hexagonal prism, and then the other was a trapezoidal prism. I've taken some different numbers to just talk through the ideas of this. I'm going to calculate the volume first, and then I'll calculate the surface area second. So the volume of this shape is going to be the area of the base, which is a hexagon, multiplied by the height. The height in this case is 12 centimeters. So what we need to start by doing is find the area of the hexagon that's given to us. And one of the nice things about a hexagon is that it's made up of equilateral triangles. So whatever the length of the side is, all of the other sides of the triangles will be the same. So because this is 8 here, I know that this length is also 8 there. So the area of the base hexagon is going to be 6 triangles, right? Let's look at one triangle. Let's draw this larger. This side is 8. When I draw the height of this here, this splits in half to be 4. And because this was an equilateral triangle, all of the angles are 60 degrees. So what I've created is a 30, 60, 90 triangle here. And so this side is 4 times the square root of 3. That's always going to be the case. You can use the Pythagorean theorem to find that, but that's one of the special triangle relationships we talked about back when we were looking at area and perimeter of polygons. So one triangle area will be 1/2 the base. Remember that the base is 8. And the height is 4 square root 3. So one triangle is going to be 16 times the square root of 3. So if we multiply that by 6, the area of one of the hexagons is going to be 6 times 16 square root 3, or 96 times the square root of 3. So now we can find the volume. The volume is going to be the area of the base times the height, or 96 times the square root of 3 multiplied by 12. So the exact answer is 1152 times the square root of 3. Actually, let's write square. This is going to be units, or this is centimeters. And if I plug that into the calculator to get a decimal approximation, I would get 1995.3 centimeters cubed. Now, if you were close to the answer, I gave you credit. If you did not get the answer close, I mean, if it was off by 10 or 50 or some large number, I did not give you credit. So if you were within, 1 or 2 of these volume and surface area answers, I did give you credit. So if I marked it wrong, which you would know because I gave you half the points, if I marked it incorrect, it's because you were very, very off in your answer. All right, so now the next thing that we'll do is calculate the surface area for this. So the surface area of this is going to be two bases plus all of the sides together as one huge rectangle. So bear with me while I draw a picture. So there are 6 sides. I'm going to have a hexagon for one of the bases, and then another hexagon for the other base. We already found the area of one of the bases. We said that it was 96 times the square root of 3. So we already know that this is 96 square root 3, and this is also 96 square root 3. And the sides are going to be the perimeter the perimeter of the whole hexagon multiplied by the height of the prism. So what I'm saying is that, let me erase this, all of the sides together is going to be, if I took this whole perimeter and then multiplied it by this, that height, that's going to be this rectangle. The height is here, which we said was, I think, 12 centimeters. And then this length here is going to be 8 for each side times 6, 48 centimeters, right? Because I've got 6 sides and they're each 8 centimeters long. So the surface area for this will be 2 times 96 times the square root of 3, that's for the two bases, plus 12 times 48, that'll get all the sides together. So this is 192 times the square root of 3 plus 576 centimeters squared. Now remember, because one of these terms has a square root and the other doesn't, we cannot combine them together. This is the exact answer. The approximate answer is, if I plug that into the calculator, 192. I'm getting 908.6. The next problem that I want to do, just because it's related, is surface area and volume of a trapezoid. The process that I'm going to follow will be very similar to what I just did for the hexagon. I will start by finding the area of the base. I'm going to find the volume first. The volume for this problem is exactly the same, or the formula for this, the volume is the same as the one that I just did. It's going to be the area of whatever the base shape is, which in this case is a trapezoid, multiplied by the height of the shape. So we need to find the area of the base trapezoid. When I have a trapezoid, let's write down what the measurements are. We have that the bottom here is 4. This side is 3. Obviously, this is not drawn to scale. And this is 2, right? So for area of a trapezoid, the formula is 1/2 base 1 plus base 2. You add the two bases together, which is the top and the bottom, and then you multiply by the height. So the area of the trapezoid is 1/2 2 plus 4 times 3, which is 9. Okay. So we can find the volume pretty easily from this. The volume is going to be the area of the base, which we just said was 9, multiplied by the height. The height of this is variable c, so that'll be 7. This one is going to be 63 yards cubed, because this is the volume. All right, and then let's find the surface area. Similar to the problem that we just did before with the hexagon, we'll take two bases and then we'll add the perimeter of the shape and multiply it by the height to get all of the sides added together. So we need to figure out the perimeter of this hexagon, or sorry, trapezoid. I'm going to redraw this picture and draw it more to scale so we can look at it better. Let me erase this for a second. Let's make this shorter. And then we'll make this longer like this. Okay. Because we need to find this side right here. Let's call it C. There's a triangle that's created, right? This is 2, and so this is also 2. And this side is 3. So to find side C, it's going to be 3 squared plus 2 squared. C squared is equal to 13. So C is the square root of 13 in this particular case. Okay. So the perimeter of that shape is 3 plus 2 plus 4 plus the square root of 13. That's the area or the distance around that trapezoid. And I'll multiply that by the height of the shape, which was 7. And then 2 bases, each base we said was 9, right? This is the base right here. So we have 2 times 9. So putting that together, I've got 18 plus 9 square root 13 by 7. 18 plus 63 times the square root of 13. And this is, I think it was yards. This is yards squared. This is the exact answer. And the approximate answer, on the exam, I accepted either approximate or exact answers. 245.1 about yards squared. All right. The next problem is the pentagonal pyramid. This one was a little more challenging because we weren't given all of the dimensions and we had to find them. So let's start by finding the volume. The volume of this shape. Prisms and pyramids have the exact same formula for volume. The only difference is we take 1/3. So the volume of a pyramid will be 1/3 the area of the base, in this case it's a pentagon, multiplied by the height. So let's find the area of the pentagon. It's going to be 5 triangles, right? 5 smaller triangles. Like this. Now, I know that the side is 5.8. Now, one of the things that you need to be aware of is that some people made the same assumption that there was for a hexagon. In a hexagon, the lengths of all of these sides of the triangle are the same. That's only true for a hexagon. That's not true for a pentagon. In pentagon, the dimensions are different because the angles are different. They're not equilateral triangles. I do know, I can figure out the apothem, right? The apothem is going between the height of the pyramid and the slant height. So this internal triangle here, L is equal to 5 and H is equal to 3. And so using Pythagorean theorem, that means that the apothem is 4. And that helps me because that's this dimension here. This is 4. So each triangle there is, I've got the base and I've got the height. So the area of the base pentagon is going to be 5 times I've got 1/2. The base is 5.8 and the height is 4. So plug that into calculator. I'm getting 58 for the base of the pentagon. Okay. Now we can calculate the volume, which is 1/3 the area of the base, which is 58, times the height of the pyramid, which is 3. So I'm getting 58 feet cubed. Now it looks a little bit weird that the area of the base and the area of the volume are the same, but the base is in square units and the volume is in cubic units. They're different measuring systems, right? All right, and then let's figure out the surface area. The surface area will be 1 base plus 5 side triangles. So let's think about each side triangle one at a time. We know that the bottom of that triangle is 5.8 because it's the side of the base. The height is the slant height, which is 5. And so each of those triangles will have 1/2 5.8 times 5 in this case. These are the triangles I'm talking about, the triangles that make up the sides of the shape like this over here, right? And the base we said was 58. So let's add this all together. This is 72.5. So I'm getting 130.5 feet squared. All right, last problem to tackle is the irregular shape. Some people got this right. Some people, I think, counted in the surface area, they counted the place where the two items would be connected, where that semi half cylinder and the rectangular prism would be connected, and that's not considered. Think of this as a package, and we're wanting to know how much wrapping paper would be just on the outside, not anywhere on the interior. Even though it looks like two separate pieces, we're intending for it to be stuck together as one item. So when we figure out the volume, there's a couple ways to do it. We could follow the similar idea that we did in the last problems where we figure out the area of the base, and the base is half a circle and a rectangle added together, and then multiply by the height. Or what most of you did looking at your work was for the volume, you said, okay, it's going to be a rectangular prism, and then you added 1/2 of a cylinder. So the rectangular prism, that part's easy, right? It's just length times width times height. So 4 by 5 by 10. For this, a cylinder, the way that we find the volume is we take the area of the base, which is a circle, so pi r squared, and then we multiply it by the height. In this case, height is the variable to L. I've got the 1/2 in front because we've got that cylinder cut in half. So this will be 200 oops, that should be a plus 1/2 3.14 The radius here is going to be 2.5. And L is 10. So for the radius, I'm looking at this right here because that's going to be the same length here. W is 5, so I'm getting 2.5 for the radius there. And then let's see what I get here. Oops, that needs to be squared, right? 2.5 squared. I'm getting 98.125. So that would be 298. Most people rounded to the 10th place, so 0.1 inches cubed. Okay. And then we need to figure out the surface area. So what I'll do is I'll draw the net of this to figure out the surface area. So if we think about the bottom of the shape, I have two of the items that are front back, right? This would be H times W. I have two of those. Or I guess those would be the two sides based on the way this is. And then I've got the front and the back, which is H times L, right? Front and back. And then I have the bottom. The bottom is W times L. I don't have a top to that rectangular part because it's connected to the cylinder. So H times W is 20, right? This is 20, this is 20. H times L is 40, this is 40, this is also 40. And then W times L is 50. So those are all the sides of the rectangular prism. Now thinking about the cylinder that's on top, the half cylinder, I actually have a half circle, and then I've got another half circle, one on each of the sides, right? I've got two half circles, so really together, that's going to be one whole circle. And then I have this side piece, which wraps around. This is going to be half of the circumference of the circle because it's right here, it's wrapping right here. And then this dimension is the height. So what's the area of the circle? Area pi r squared. Well, we already saw in the last part of the problem that the radius was 2.5, right? So the area here is going to be pi, or 3.14, times 2.5 squared. That's just the circle base. That is 19.625. I'm going to make that red so that I can have all these know what to add up together. 19.625. And then circumference, to get all the sides, circumference is pi times diameter. So I want to do 1/2 of the circumference, which is 1/2 times 3.14, and the diameter is 5. So let's see what that is. I'm getting 7.85. And the height was 10. So this part is 78.5. Right, so I'm going to add everything in red up together. So the total surface area I have 2 sets of 20, that was 40. I have 2 sets of 40, that was 80. And I have a 50. And then I have 78.5 and 19.625. So for my surface area, I'm getting 280, oops, I transposed those numbers. 268 point, I'm going to round this, 0.1. And I think this was, what were our units here? Inches squared. Let me just double check that calculation. Yep. All right. Thank you for watching. I know some of you may still have other questions, but I wanted to at least answer the majority of the questions through this video, and then we can make individual appointments through Zoom if you have further questions. Have a great day.